Good afternoon, class. We are looking at chapter 6, trigonometric functions. And here's 6.1, graphs of the sine and cosine functions. So we are going to look at graphs of the sine and cosine function, graphs of the tangent and cotangent, cosecant and secant. PS stands for phase shift. More graphs, phase shift, sinusoidal carefully. So the objectives for the section are graphing sine functions of the form y equals a sine omega x by transformation. Same thing for y equals a cosine omega x. Determine the amplitude and period of sinusoidal functions. Graph sinusoidal functions using key points, finding an equation for a sinusoidal graph. Reminding everyone of what we have learned, a unit circle versus a general format, x squared plus y squared equals r squared, centered at 0, 0. When the radius is 1, gives rise to the unit circle. And with that in mind, x squared plus y squared equals 1. A pair has coordinates x comma y. Y represents the sine, x represents the cosine function, and the rest basically follow. Tangent is y over x, which is the ratio of sine over cosine. The rest of them are reciprocal of the others. In general, x squared plus y squared equals r squared. And then sine, which was y here, is y over r. Cosine, which was x, is x over r. And the rest of them follow accordingly. We also looked at some properties of trig functions and fundamental identities. For example, x squared plus y squared equals 1, which represent a point P with coordinates cosine and sine. Periodic function. All trigonometric functions are period. The period is 2 pi for all of them, except for tangent and cotangent, which is pi. That means multiples of those, they will result in the same function, sine of theta plus 2 pi or 2k pi sine theta, and so on. Even and odd properties, as you recall, even function means f of minus x is f of x. Odd function means f of minus x is minus f of x. All trigonometric functions are odd functions except cosine. Cosine of minus x is cosine x. And with that goes secant, because secant is the reciprocal of that. Secant of minus x is also secant x. And this will give rise to Pythagorean identity, sine squared plus cosine squared equals 1. And then we use that to look at the rest of them. Tan squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. Quotient identities, tangent is sine over cosine, cotangent is cosine over sine. Reciprocal identities, cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Those are the fundamental identities in general that we have seen. And now graphs of the sine and cosine function. Let's go with y equals sine x. As we did in the beginning, whenever we wanted to graph any function, we would start with points. So let's just pick up some easy points, common arcs, and figure out the answer. For example, if we pick 0, we know sine of 0 is 0. Pi over 6 or 30 degrees, the sine is 1/2. Pi over 4 is square root of 2 over 2. Pi over 3 is square root of 3 over 2. Pi over 2 is 1. Now 5 pi over 6. The reference arc is pi over 6. So it's the same as that. You have to figure out the sign. In the second quadrant, sign is positive. So that is also 1/2. Pi is 0. 7 pi over 6. Again, the same as pi over 6 as far as the reference arc goes. So it's the same value, 1/2. But in this quadrant, which is the third quadrant, sign is negative. So negative 1/2. 3 pi over 2 is -1. 11 pi over 6. Again, the same as pi over 6 because pi over 6 is the reference arc. However, 11 pi over 6 puts us in the fourth quadrant, and sine is negative, so -1/2, and 2 pi is 0. So we get the following, everybody. So those are the pairs. 0, 0, pi over 6, 1/2, all the way to the end. And if we plot them carefully, this is a sine wave, if you call it. Sine function, sine wave. X is between 0 and 2 pi. We are going to use this concept later on 4 arcs. Notice this portion is referring to this one. This portion is referring to this one. This is this one. This is the fourth arc, this part, which results in 5 key points. We will look at that later on. But for now, graph sinusoidal functions using key points for arcs coming up. This is the synopsis of that, would be to use these endpoints of those arcs. 1, 2, 3, 1, 2, 3, 4 arcs. This is what we are going to use. Ultimately, that's the fastest and easiest way to graph any sinusoidal function. So that's a graph. Needless to say, we can continue indefinitely on both sides, which gives rise to the domain being all real numbers. So the sine function, y equals sine x, is a fundamental trigonometric function with several important properties. Number one, it's periodic. The sine function is periodic with a period of 2 pi. This means that sine of x plus 2 pi equals sine x for all x. Amplitude, domain, and range. The amplitude of the sine function is 1. This means that the maximum value of sine x is 1, and the minimum value is -1. 1 and -1. Hence, the range of the sine is from -1 to 1. The range is from -1 to 1 along the y-axis. Its domain, all real numbers. Summary, symmetry and odd function. The sine function is an odd function. This means that sine of minus x is minus sine x. Its graph is symmetric about the origin. So if you connect any point, pick a point connected to the origin, and you go the same distance, pick this point, connected to the origin. And if you go the same distance, it must give you another point on the graph. That's the concept. Its graph is symmetric about the origin. Key points, x-intercepts. The sine function crosses the x-axis at integer multiples of pi, i.e. x equals n pi, 0, pi, 2 pi, 3 pi, and so on. Where n is an integer, the function reaches its maximum at x equals pi over 2, and then if you add 2 pi, or better yet, multiples of that, 2n pi, and its minimum value occurs at x equals 3 pi over 2, and then if you add 2n pi. The y-intercept is 0 because it's at 0, 0. We're talking about the basic function. You should know the graph. The basic function, a complete cycle is here. And then we expand. Waveform. The graph of the sine function is a smooth continuous wave that oscillates between its max and mean, creating a sinusoidal waveform. Relation to the unit circle. The sine function can be defined as the y coordinates of a point on the unit circle x squared plus y squared equals 1. These properties make the sine function essential in various fields such as physics, engineering, and signal processing. So, y equals sine x, period t equals 2 pi, amplitude is 1, y equals a sine omega x, period is 2 pi divided by the coefficient of x, this is omega, and amplitude is the absolute value of a. So that's the synopsis of the information about the sine function, everybody. And of course, domain, all real numbers from negative to positive infinity. Let's look at the graph of y equals cosine. In which case we are going to do the same thing. We're going to pick up some pairs to do the work. And to do so, we're going to go with easy numbers. We are going to go with common arcs. 0, cosine of 0 is 1. Pi over 3, 1/2. Pi over 2, 0. 2 pi over 3. The reference arc is pi over 3. That means the same as this one, 1/2. But is it positive or negative? 2 pi over 3 puts us in the second quadrant. Cosine is negative, so it makes it negative 1/2. At pi, cosine is negative 1, one of those quadrantal angles. 4 pi over 3, again, just like pi over 3, 1/2, but positive or negative. This is in the third quadrant, also negative. 3 pi over 2 is 0. 5 pi over 3 is the same as pi over 3, 1/2, positive or negative? Positive, because it's in the fourth quadrant. In the fourth quadrant, cosine is positive. At 2 pi is the same as 0, 1. So those are the pairs. We graph it, looks like that. And again, this is a complete cycle between 0 and 2 pi class. This, of course, continues indefinitely on both sides, okay? Again, let's look at 4 arcs. This part, this part, this part, the last part. I want to make sure we understand what's going on. 0 to 2 pi is cut into 4 sub-intervals. By dividing 2 pi by 4, we get pi over 2. So 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi. And that's what we did with the sine. So we have 4 subintervals and key points. 1, 2, 3, 4, 5 key points. So graph sinusoidal functions using key points, 4 arcs. Again, so this is 1, this is 2, this is 3, this is 4. And those are the key points. The max 0, 1, and 2 pi 1, the mean pi negative 1, and the intercepts pi over 2, 0, 3 pi over 2, 0. All right, let's discuss the cosine functions in details. Y equals cosine function. Again, this is a complete cycle and it continues indefinitely on both sides. So the cosine function y equals cosine x is a fundamental trigonometry function with several important properties. Number 1, period. The cosine function is periodic with the period of 2 pi. That means cosine of x plus 2 pi is cosine x for all x. Amplitude, domain, and range. The amplitude of the cosine function is 1. This means that the maximum value of cosine is 1 and the minimum value is -1. Hence, the range is from -1 to 1. Its domain is all real numbers. Symmetry and even function. The cosine function is an even function. This means that cosine of -x equals cosine x. Its graph is symmetric about the y-axis. Look at the y-axis. The one on the right is the same as on the left. Key points x-intercepts. The cosine function crosses the x-axis at odd multiples of power 2. That means 2n plus 1. This represents a number which is odd, times power 2. Remember, n is an integer. N is an integer. For example, if n is 0, we look at power 2. If it's 1, 3 power 2, and so on. 5 power 2, 7 power 2, and so forth. The function reaches its max of 1 at x equals 2n pi. So for example, here and here. And its minimum of -1 at x equals pi plus 2n pi. For example, here, and it continues like 3 pi, -1, and so forth. The y-intercept is 1. This is 0, 1. Waveform. The graph of a cosine function is smooth, continuous wave that oscillates between its maximum and minimum values, creating a sinusoidal waveform. So y equals cosine x. Relation to the unit circle. The cosine function can be defined as the x-coordinate of the point on the unit circle, x squared plus y squared equals 1. Its properties make the cosine function essential in various fields such as physics, engineering, and signal processing. Just like sine. Y equals cosine, period is 2 pi, amplitude is 1. But if we go with a cosine omega x, period is t equal 2 pi divided by omega, amplitude is absolute value of a. Simply by definition, it becomes the absolute value by definition of an amplitude. So it's very straightforward, everybody. Let's look at some examples. Needless to say, the domain is all real numbers. This continues indefinitely from negative to positive. All right, so we want to graph y equals 3 sine x by transformation. Well, in the case of y equals sine x, the period is 2 pi, the amplitude is 1. In the case of a sine omega x, the period changes 2 pi over omega, amplitude is absolute value of a, just to refresh everyone's memory. And so here's the basic sine function, y equals sine x. By transformation, we are interested in getting y equals 3 sine x. So we multiply the y coordinate by 3. So we are stretching it by a factor of 3 along the y-axis. So vertical stretch. So for example, this one has the same x coordinate, power 2, but the y becomes 3. This one has the same x coordinate, 3 power 2, but the y coordinate is -3, and the rest continue. What happens is that the domain doesn't change, it's all real numbers, but the range, this has a range of -1 to 1, but this has a range of -3 to 3. That's the effect of this move, everybody. Y equals negative sine 2x, reminding everybody of what we wrote in the previous page as far as a basic sine function. the period is 2 pi, amplitude is 1. But if it's not a basic sine function, for example, y equals a sine omega x, the period changes. You divide 2 pi by the coefficient of x, 2 pi over omega. The amplitude over here, the coefficient of sine x is 1, the amplitude is 1. Over here is a, so the amplitude is absolute value of a, even if it's negative. So in this case, for example, negative or positive makes no difference. The amplitude remains as 1. But let's go with the basic function. Y equals sine x. We know the graph. You really should know the graph of a sine function, and at the very least through one complete cycle. Very interested in one complete cycle. Then we stretch it on both sides indefinitely, and in some cases they may ask only for one complete cycle. So let's have this negative in front. The effect of that this will flip over with respect to the x-axis class. So multiply by -1, reflect about the x-axis. So the same thing, we're going to reflect it. For example, power to 1 comes down here and it becomes power to -1. 3 power to -1 goes up here, becomes 3 power to +1. This comes down 5 power to -1 and so forth. But we are interested in a few points. So minus power to -1. It's minus power to +1. The period hasn't changed, it's still 2 pi. Now, the next is the effect of that. The effect of that, if we replace the x by 2x, it's a horizontal compression by a factor of 1/2. So replace x by 2x, horizontal compression by a factor of 1/2. So what happens here doesn't change, but this one, and look at the period, which is 2 pi. Now, the period 2 pi divided by omega, 2 pi divided by 2 becomes pi, which means all of this, all the x coordinates will be cut in half. So the y coordinates don't change. For example, here, power 2 becomes power 4. 3 power 2 becomes 3 power 4. Minus power 2 becomes minus power 4. What about the y coordinates? They do not change. So the period 2 pi, the period 2 pi, the period has changed to pi, and this is y equals negative sine 2x. So the effect is the period has changed, the domain hasn't, the range hasn't. Therefore, we're going to write t is 2 pi over omega, or 2 pi over 2 pi. Domain is the same as the other two. Range, this was from -1 to 1, this one from -1 to 1. This hasn't changed either. Graph y equals 2 cosine 3x by transformation. And again, reminding everybody about the cosine. When y equals cosine x, the period is 2 pi, the amplitude is 1, just like sine. When y equals a cosine omega x, the period changes to 2 pi over omega. You divide by the coefficient of x, and the amplitude is the absolute value of a, again, just like basic sine and basic a. If we change the sign, same thing with the cosine. So here's a basic cosine function. So pay attention to one complete cycle. And we want to change it accordingly. So if we go with number 2, that means if we multiply it by 2, we have a vertical stretch of 2. So this point has coordinates pi, -2. This one has coordinates 2 pi. 1 times 2 is 2. This is 0, 1 becomes 0, 2. So this goes up to 0, 2. This goes down to pi -2. This goes up to 2 pi 2. That's the effect of this number 2 in front. Now, the effect of 3 is that if you look at the period here is 2 pi, so is the period here. The period is and now replace the x by 3x. The effect is that it compresses along the x-axis by a factor of 1/3. So this 2 pi, this period, is really divided by 3. That means the y coordinates remain unchanged, but the x coordinates, this one, minus pi over 3, this one, pi over 3, this one, 2 pi over 3. That's the effect of that. So take a look. So the period is 2 pi over 3. Let's see. The domain was all real numbers. Same here, same here. The range was from -1 to 1. The range changed as a result of this transformation to -2, from -1 to 1 changed to -2 to 2. So that is the new range. So the period has changed, the range has changed. You may have noticed that sine seems to be the same as cosine, except it has been shifted. So if you look at the sine function, the blue one, and look at the cosine function, the red one, okay, if you shift one of them, really doesn't matter which one, but normally we shift the cosine by pi over 2 to the right, and they become identical. So this red one, just move it by pi over 2, it goes at top of the other function, becomes the same thing. Y equals cosine x, y equals cosine of x minus pi over 2, they become the same thing. So the blue one, you know it's the graph of sine x. Now, if you were to verify that with a graphing calculator, all you had to do would be y1 is sine x, y2 is cosine of x minus pi over 2, and what do you see? How many graphs? You see only one. One graph. And that shows the two functions are identical. Okay, everybody. The two functions are identical. That's important to notice and understand that. Okay. Determine the amplitude and period of a sinusoidal function. Again, reminding everybody about the synopsis of what we have discussed, whether we are dealing with sine or cosine. Makes no difference. The basic function t is 2 pi, amplitude is 1. Whether we talk about a sine omega x or y equals a cosine omega x, where omega is positive, makes no difference. T is 2 pi over omega, amplitude is absolute value of it. By the way, speaking of omega being positive, if the argument of any sinusoid or any trigonometric function is negative, just make sure you get rid of the negative sign for each one. If it's odd, it comes out, makes it negative. If it's even, such as cosine and secant, it has no bearing. So you got to get rid of that first. So this is an example of a graph of y equals a sine omega x. See, the sine function, and this is 2 pi over omega. The complete period of 2 pi has shrunk by a factor of omega, 2 pi over omega, and we are taking a to be positive. Now, y equals negative 4 cosine 3x. Obviously, the amplitude is the absolute value of negative 4, which makes it 4. The period is t equals 2 pi over omega, 2 pi over 3. Y equals 3 sine 4x. The amplitude is the absolute value of 3, which is 3, and the period is 2 pi divided by 4, which makes it pi over 2. All right, here's the summary of using the key points. Steps for graphing a sinusoidal function of the form y equals a sine omega x or y equals a cosine omega x using key points. Number 1, determine the amplitude a and period t equals 2 pi over omega. Number 2, divide the interval of 0 to 2 pi over omega, the entire interval, into 4 subintervals of the same length. So divide this number in 4 in essence. Use the endpoints of these subintervals to obtain the 5 key points on the graph. When you have 4 subintervals, you have 5 key points. Plot the 5 key points to obtain the graph of one cycle, connect and extend on each side to make it complete. What do we mean by that? Let's find out. Graph sinusoidal functions using key points. Y equals 4 cosine 2x using key points. We start with the amplitude, and again, the information is with here. We should know that. The amplitude is the absolute value of 4. The period t equals 2 pi over omega, which makes it 2 pi over 2, or simply pi. So a period of 0 to pi, that's what it has. A complete cycle goes from 0 to pi. We are going to cut this into 4 equal parts. So we're going to divide this number by 4. Gives us pi over 4. So that means now the idea is this class. Here's 0, here's pi. We're going to cut it into 4 equal parts. And so this is pi over 4. and the other one is add pi over 4. You get 2 pi over 4, which means pi over 2. Add pi over 4, you get 3 pi over 4. And if you add pi over 4, you must get pi. If it doesn't happen, we've made a mistake somewhere. So the sub-intervals are as follows: 0 to pi over 4, pi over 4 to pi over 2. I put 2 pi over 4 on purpose so you see how we get that. And then 2 pi over 4, meaning pi over 2 to 3 pi over 4, and 3 pi over 4 to pi. So let's plug in each endpoint. I'm going to plug in 0 here. Class, if I plug in here, so let me actually calculate all of them. So we're going to plug in. So I want y equals 4 cosine 0. I get 4 times 1 equals 4. So that means I have the pair 0, comma 4. That's my first. The second one is pi over 4. 4 cosine of 2 times pi over 4, which means 4 cosine of pi over 2. You know, cosine of pi over 2 is 0. 4 times 0 is 0. So we got pi over 4, we need pi over 2. Y equals 4 cosine of 2 times pi over 2 makes it 4 cosine of pi. And you know that is -1. So that gives us -4. So just to make sure what we got here, okay, I forgot to put, so this is one pair. This one is pi over 4, 0. This one is pi over 2, -4. Now the next one would be 3 pi over 4. So y equals 4 cosine of 2 times 3 pi over 4, which makes it 3 pi over 2, which makes it 0, which gives us the pair 3 pi over 4, 0. And there is one more, pi. Plug in pi. We get y equals 4 cosine of 2 pi, which you know it to be 1 times 4 is 4, which means pi comma 4. So we got those 4 pairs. Next time I will explain one or two. You should be able to figure out the rest of them on your own. So all you have to do, and I'm going to erase the work so we can show the rest of them. All you have to do, you have a rectangular coordinate system, and you are going to plot 5 pairs. Okay, just for the sake of argument. So just to give you an idea, let's say this is pi. You cut it in 2 parts, becomes pi over 2. 2 parts, this one is pi over 4. 2 parts, this one is 3 pi over 4. And for example, let's say this is 1, 2, 3, 4. So here's 0. Pi over 4, 0. Pi over 2 minus 4, somewhere it's here. 3 pi over 4, 0. Pi 4. And it looks like that, which is a lot better than what I have. And now just connect them. It's a complete cycle. They didn't say about one cycle, so we have to go indefinitely on both sides. That's the graph. I hope you understood what we did. We're going to repeat this with a couple of questions. This is the fastest and easiest way to graph sinusoidal functions. Graph of y equals negative 3 cosine of power 4x. The amplitude is absolute value of negative 3, which makes it 3. The period is 2 pi divided by power 4, which makes it 8. We cut this into 4 equal parts. We get 4. 8 divided by 4 equals 2. So we're going to go from 0 to 2, 2 to 4, 4 to 6, 6 to 8. So I'm going to go back over this one more time because it was dealing with easy numbers. I went through that fast. Absolute value of negative 3 is 3. 2 pi divided by power 4 is 8. Cut date into 4 equal parts, you get 2. So you go from 0 to 2, 2 to 4, 4 to 6, 6 to 8. Now you're going to plug in. I'm going to show you a couple of them and the rest of them we can figure out. 0 is easy. If I plug in 0 here, I get 0. Cosine of 0, 1 times negative 3 is negative 3. Let's actually write it. So I'm going to write 0. If I plug in 0, y equals minus 3 cosine of 0, which makes it minus 3 times 1, which is minus 3. Let's go with 2. If I plug in 2, I get y equals minus 3 cosine pi over 4 times 2 is pi over 2. You should know cosine of pi over 2 is 0. And so you get 0. I'm going to do one more. 4. If I plug in 4, y is minus 3. So let me plug in 4 here instead of x. If I put 4 instead of x, I get minus 3 cosine of pi. Again, because 4 times pi over 4. And we get minus 3. Cosine of pi is negative 1. We get positive 3. If I if I plug in 6, I get y equals minus 3. 6 times pi over 4. Cosine of 3 pi over 2 is 0. I get 0. If I plug in 8, 8 times pi over 4, 2 pi. So if I plug in 8, I get y equals minus 3 cosine. Pi over 4 times 8 is 2 pi. Cosine of 2 pi is 1. I get negative 3. And those are the pairs, everybody. Again, I showed you all of them. You should be able to figure this out in no time. They're all common arcs. So you draw a rectangular grid and you plot 0, negative 3, 2, 0, 4, 3, 6, 0, 8, minus 3, put them all together. Let it go indefinitely on both sides, and you're done. By the way, the range has changed from -1 to 1 for the basic one to -3 to 3, okay, because of the amplitude. Again, it's very straightforward. I hope everybody is following that. If you cut it into 4 equal pieces, it makes life really easy. We want to graph y equals 5 sine 3x. And again, we're going to start with the amplitude is 5 because it's the absolute value of 5. T is 2 pi over omega, or 2 pi over 3. And the period has to be cut into 4 equal parts. If I divide this one by 4, that means 2 pi over 12. That means pi over 6. So I go from 0 to pi over 6, then pi over 6 to pi over 3, because you got to add pi over 6. Then pi over 3 to add pi over 6 becomes pi over 2, pi over 2 to 2 pi over 3. I hope you can see how we can do that. So all you have to do, write the first one, and then this becomes this one. These two are the same. Notice these two must be the same. And then you add pi over 6. These two must be the same. These two must be the same. And now, maybe a couple of them I'll show you. So I'm going to go with 0. If I plug in 0 class here, y equals 5 sine of 3 times 0 is 0. Sine of 0 is 0. I get 0. I'm going to go with pi over 6. I'm going to go with pi over 6. So y equals 5 sine 3 times pi over 6. That means pi over 2. You know sine is 1. Sine of pi over 2. So we have 5. So this means 0, 0. This means pi over 6, 5. I'm going to just mention it because it's easy. If I put pi over 3, 3 times that becomes pi. Sine of pi is 0, 5 times that is 0. Pi over 3, 0. Okay. If I put pi over 2, 3 times pi over 2 makes it sine -1 times 5 is -5. If I put 2 pi over 3, 3 cancels out the 3, I get 2 pi. Sine of 2 pi is 0, so that's 0. So I hope you see the 5 pairs. You should have no problem evaluating it. I showed 2 of them, and the rest of them I explained. You should have no problem with that. So plot the pairs. 0, 0, pi over 6, 5. This is pi over 3. It doesn't show good, but it's pi over 3, everybody. 0. This is pi over 2, -5. And this is 2 pi over 3. Okay. Put them together, and it looks like that. Nice and smooth, everybody. Very smooth. And let me clean up. And if you continue indefinitely on both sides, it'll look something like this. We're going to get this graph, y equals 2 sine of minus pi over 2 over x using key points. And again, we're going to see what to do. The very first thing I want you to notice is that if you have a negative as part of the argument, get rid of it. All of trigonometric functions are either odd or even functions. In other words, you can either get rid of it or bring it out. Okay, and of course, as you know, sine is an odd function, so negative comes out. This is what I mean. So we're going to bring it out. Now you deal with it. It's a lot easier. The amplitude is -2, although you can graph it just the way it is, but it's much better if you go this route. Okay, because you want omega to be positive. Remember that. Omega, you want it to be positive. So the amplitude is the absolute value of -2, which makes it 2. And the period 2 pi divided by pi over 2. 2 pi divided by pi over 2 makes it 4. So very simple. The key for this question was to, what do you do with the negative sign? Now, you cut that into 4 equal parts, you get 1, which means you're going to go from 0 to 1, 1 to 2, 2, 3, 2 to 3, 3 to 4. That's all. And now all you have to do, plug in. And I'll show you how fast you can come up with the answer. If I plug in, and I'm going to plug it into this one, okay? If I plug in 0, I get 0. Sine of 0 is 0 times the number is 0. So 0 gives me 0. If I plug in 1, I get pi over 2. Plug in 1, pi over 2. Sine of pi over 2 is 1 times -2 is -2. I plug in 2. 2 gives me pi, sine of pi is 0. It doesn't matter what happens. Okay. Plug in number 3. 3 pi over 2, sine is -1. Times -2 is +2. And if I plug in 4, I get 2 pi, sine is negative. So I hope you see what happened. Again, I discussed that. I pick one of them and I do it for you. Let's say 3, and I, for example, number 3. If I plug in y equals -2 sine of pi over 2 times 3. So sine of 3 pi over 2 is -1 times -2 makes it +2. So therefore, you're looking at the pair 3, comma 2. Okay, it's all of them are easy common arcs. That should be a piece of cake, class. So we have those, and let me erase my work again. Plot 0, 0, 1, -2, 2, 0, 3, 2, 4, 0. 0, 0, 1, -2, 2, 0, 3, 2, 4, 0, and put them together. Smooth curve. Continue indefinitely on both sides, and you're done. We're going to continue with graphing sinusoidal functions using the key points graph y equals -4 cosine of pi x minus 2 using key points. Now, there are two ways to do this, class. One is to completely ignore that and write it y equals -4 cosine pi x, finish the job. What is the effect of that? Shift it down by 2 units. That's one easy and fast way to do it. The other one is that just the way it is, deal with it. You come up with your 4 points, the 4 sub-intervals and the 5 key points, put it into this one and evaluate it. That works too. But I think this is a tad easier. let's just ignore the -2, deal with that. Amplitude, absolute value of -4, which makes it +4. Period, 2 pi divided by omega, 2 pi divided by pi, which makes it 2. Divide this by 4, you get 4 equal parts, 1/2. So we're going to go from 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. So those are the 4 subintervals. And again, remember, we are going to go with this function, okay? We are going to deal with this one. And we're going to plug in. So if I plug in 0, I get cosine of 0. Cosine of 0. Let me just write this and then I erase it. Let's see. Let's write it here. Y equals -4 cosine 0. You know cosine 0 is 1. And I get -4. And that gives me the pair 0, negative. Now let's plug in 1/2. Y equals -4 cosine of 1/2 times pi power 2. You know cosine of power 2 is 0. This is 0. Therefore, 1/2 gives me 0. Let's do 1. Y equals -4 cosine of pi times 1, which makes it pi. You know cosine of pi is -1, gives me +4. So the coordinates are 1, 4. Okay. If I put 3/2, class, I get here 3/2 times pi, cosine is negative, cosine is 0, so that gives you 0. If I put 2, 2 pi, cosine of 2 pi is +1, times -4 becomes -4. Here's the pairs. Okay. So I hope you realize it's fairly easy to get the pairs. The pairs are not too bad. So plot them. All you have to do, plot the pairs. 0, -4, 1/2, 0, 1, 4, 3/2, 0, 2, -4, and it looks like this. 0, -4, 1/2, 0, 1, 4, 3/2, 0, 2, -4. Put them together. The graph looks like that. And if you continue indefinitely, it looks like. Now, this is the graph. That's not what we want. What we want is this. So we have to shift this down by 2 units. Shift it down by 2 units, which means if you look at this pair, for example, you get -1, 2. This one, you get -1/2, -2. This one, 0, -4 changes to 0, -6. Okay. I don't know, 1, 4 becomes 1, 2, and so on. 1/2 0 becomes 1/2 -2. 3/2 0 becomes 3/2 -2. So subtract vertical shift down 2 units. This is what you get. Very straightforward, I hope, everybody. Find an equation for the graph. So I hope you recognize this as a cosine function. This is 0, 3. This is 1/2 -3. This is 1, 3. And it looks like cosine. So you're going to write y equals a cosine omega x. So we are looking at one complete cycle. The amplitude is, this is going to go from -3 to 3. The maximum is 3. The minimum is -3. The amplitude is 3. The period is 2 pi divided by omega, and it's equal to 1. Period is 2 pi divided by omega equals 1. So omega must be 2 pi. Therefore, replace the a with 3 and omega with 2 pi, you get 3 cosine 2 pi x. What about here? Finding an equation for a sinusoidal function, find an equation for the graph shown. Let's put the easy points that we see: 0, 0, 2, 0, 4, 0. How about 1, -2, 3, 2? This is a complete period of 4. So this looks like a sine function. So y equals a sine omega x. And the amplitude go from negative to 2, minimum to maximum. So the amplitude is 2. And you really should recognize that this is a reflection over the x-axis of the sine function. So the amplitude, which is the absolute value of -2, and so the a is -2. The period is 4. That means 2 pi over omega is 4. That means 4 omega equals 2 pi, and omega is 2 pi over 4 or pi over 2. And we are going to replace the a with -2, omega with pi over 2, and the function y equals -2 sine of pi over 2 over x. So just a quick summary and we are done. To graph sinusoidal functions using key points of 4 arcs, 2 pi cut it into 4 subintervals for a sine. It looks like that with those 5 key points: 0, 0, pi over 2, pi 0, 3 pi over 2, 2 pi 0. And for cosine, looks like that with the key point 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1. That is very simple.